Well, hey, welcome back. We're going to do Chapter 8 in our textbook, which is covering polynomials and factoring. This one's got a few details to it that we want to be aware of. First one is adding and subtracting polynomials. So when we're adding and subtracting polynomials, a couple of things we got to keep an eye on is just combining like terms, and we're adding them and subtracting them. All right, where was I? I just got distracted. Somebody brought a pony in my room. I know, of all things, a pony. It's crazy. My room smells bad. All right, what am I talking about here? Okay, we're adding and subtracting. Oh my goodness, things are strewn everywhere, but we can pull them together. We got to get these same last names or common x's. So I have 1x to the third, so I'm going to leave that alone. 5x to the third. I'm going to look for x to the seconds. Okay, here's 1, that's positive, and here's 3. So I have a total of 1 and 3, and they're positive, so it's 4x squared. I'm going to look for my x's, so here's a negative 2x and here's a negative 4x. So I have a minus 6x, and I'm left with a 7 and a 7, so that's plus 14. So I've combined like terms, and not only did that, but I also put it in degree format, the correct degree, starting with the highest degree of 3, then 2, then 1, 0, working my way down. Let's keep going. Ooh, add or subtract. Okay, I've got some parentheses in here. What this is doing is just gonna, we're gonna subtract them. Okay. You know, there's a couple different ways to do this. I'm going to show it both ways. So 7x minus 5x squared minus 8 third x plus 4. And we're going to subtract that. Now, as I write the second one, I'm going to move them around a little bit so they're actually lined up with the one that it's interacting with. So I'm taking away, this is taking away negative 5x squared, and I'm taking away, I got a 6, whoop, that belongs over here, 6x, and I have a minus x to the third, and I've got a 10. All right, and I can subtract these, so I have 7x minus 6x, and I'm left with x. I have a 5x squared minus 5x squared. And that means that this is actually adding them together in this particular case. I have negative 5 and I'm taking away all negative 5, so I have no more x squareds left. X to the third, it's the same thing. I have a negative 8x to the third, and I'm taking away one of those, so I am left with negative 7x to the third. I have 4 and I'm taking away 10, so I'm left with 6. So if I put that in degree order, it should be negative 7x to the third. Plus x minus 6. Yep. Another way to look at it is I turned it all into, if I go to my original problem, I turned it into an addition problem, and it just switches all the signs, and then I just combined like terms on this one. So I turned it from a subtraction problem to one big addition problem. You can do it either way. Add or subtract on this one. Okay, again, I'm looking for like terms, like last names. I'm going to look this as a subtraction problem again. All right, let's continue working with this guy here. I'm going to take my 3x squared plus 7xy minus 4y squared, and I'm going to subtract x squared, so that's right here, and 3xy, which is here, 3xy, and that's positive, and a negative 2y squared. Go ahead, let me subtract these out. So 3x squared minus an x squared, I'm left with 2x squared. I have 7xy, and I'm taking away 3xy, so I end up with 4xy. And I have a negative 4y squared, and I'm taking away negative 2y squared. It's actually adding them, so I can see that as an addition problem, and that leaves me with negative 2y squared. And again, another option would be to turn it into an addition problem. So originally I could say it's adding, and that would be negative, and that would be positive. And then just combining like terms. That's another way to do this. All right, let's talk about distributing. Ooh, how exciting. So with distributing, you need to distribute the 3x in this case for number 1. Distribute the 3x to all the terms. The first term, the second term, and the third term. So 3x times 6x, I end up with 18x squared. 3x times negative 9y, I end up with negative 27xy. And then 3x times 5, I end up with 15x. You can also do it on the next one. I just have to make sure I hit all the terms. So negative 2x to the third times negative 5x to the fourth, I end up with 10x to the seventh. Negative 2x to the third times 3x, I end up with negative, and that's 6x to the fourth. Negative 2x to the third times 5x to the third, I end up with negative 10x to the sixth. Looking at my different degrees here, I see a 7, a 4, and a 6. And I want to write this from the largest degree to the smallest degree. And this would be the correct answer. Multiplying polynomials with FOIL. Let's keep going. So FOIL, as you remember, is first, outside, inside, last. That way we can distribute all the terms out. So for instance, on this one, for FOIL, you've got your first one. So you're multiplying your first, you multiply your outside, you multiply the inside, and then you multiply the last term. And that way the FOIL ends up distributing out to all of it. Pull, I haven't tried that yet. What does that do? Oh, there's the answer. What are these? Look at this. This is so cool. Like the numbers are flying everywhere. Okay, let's just do some math. That was really fun. Let's move along. Hey, we're going to go ahead and FOIL these out. Now, this x squared, x times x plus 3, the second power is actually saying x plus 3 times x plus 3. You got to be careful of that one. Some people have the misunderstanding that that means x squared plus 9. That can happen, but in this situation, that is not what we see here. We can FOIL this out, so x squared plus, that's the first, O is outside, which is 3x, I is inside, plus 3x, and last is, there's your 9. So when you, for those that have the misconception about x squared plus 9, you get your first term and your last term, but the middle term, you got to keep an eye on that because we still have a 6x involved in there. So when I FOIL this out, I get x squared plus 6x plus 9. The same is also true for number 2 here. This is saying x minus 9 times x minus not 19, but minus 9. If I FOIL this out, I end up with x squared minus 9x minus 9x plus 81. I combine like terms, I end up with x squared minus 18x plus 81. Whoa. Got some foiling going on here. All right, let's take a look at this first one. This one, yep, I'm going to do some foiling here. So first term, I end up with 64x squared with 8x times 8x. And then I do 8x times 2y, and then I put 16xy. Then I do negative 2y times 8x, so it's negative 16x squared. And I take negative 2y times 2y, and I put negative 4y squared. I combine, if I look at the middle here, those things end up canceling each other out, and I'm left with 64x squared minus 4y squared. Number 2, why don't you go ahead and pause that, you work it out, and see how we did. It's going to be a very similar thing as the first one when you have the same binomials, well, one's subtracting and one's adding. The middle term, the b term, actually cancels itself out. So I can look at squaring this first set, so I end up with 25x squared minus, and I square the last set, which is 9y squared. Number 3. Oh, there's a lot going on in this one, so this is going to be like a super FOIL. So I need to FOIL to all the terms here. So I end up with 3x times 4x squared. So I end up with 12x to the third. And I need to do 3x times x, which is going to give me, let's see, 3x times x is 3x squared. And then 3x times negative 1, which is minus 3x. And then I got to do the next batch. So negative 5 times 4x squared is going to be negative 20x squared. And then negative 5 times x squared is going to be negative 5x. Negative 5 times negative 1 is going to be plus 5. I'm going to combine my like terms on this one. Let's see what we got here. There's only one 12x to the third. Now x to the seconds, here's one, and there's one. So I have a 3 and a negative 20, which leaves me to negative 17x squared. And I'm going to look for my x's. I have a negative 3 and a negative 5. I combine those and I get 8x. And I'm left with 5, so plus 5. So that's what number 3 looks like when it is FOILed and written in the correct notation with the highest degree first, 3, 2, 1, 0. Second one's the same way. Number 4, we got some super foiling going on here. You can press pause, go ahead and work it out, and then check, see how we both did. I'm going to keep going though. Okay. When I multiply these two together, I end up with 6x to the third. Multiply it by the next term, I get 2x to the second. I end up with negative 6x. Multiply here, I get negative 12x to the second. Multiply there, I get negative 4x. Multiply the last one, I get 12. When I combine all my like terms, I end up with 6x to the third minus 10x to the second minus 10x plus 12. My 10x to the seconds come from these guys here. And my x's come from here. And I'm just combining those terms. Just keep an eye on those details. Okay, factoring. You know, I'm going to pause this and lay out like a pretty big full screen of when you're factoring something, a conversation you want to be having with yourself. So I'm going to press pause and then I'll be back in a moment. All right, there's a lot of notes on these couple pages here, so you might want to pause them and just kind of take a look. So when you're factoring, the first thing you want to do is find the greatest common factor, as you saw in my example up there. I'm going to scroll down, and if you don't have that, you've got these other things to consider. For first thing, you want to look at your A term. If A equals 1, like in red here, then you can do what I created over here, this little x situation. So I created this x because I'm asking myself, what times what gets me 6, that when I add them together I get 5, and I found the 3 and the 2. And I did it the same for down here. Because my A term is 1, I went over here and kind of drew that x, and I said, what times what gets me 6, that when I add them together I get, not 1, I get 7. That's what I'm looking for. There it is. And not just any 7, but negative 7. That would make more sense. That would make that true. When I go over to the blue, that's if my A term is not 1, and in this case it is 8. I work through that. I need to do 8 times 3, and I get my 24, and I still run the same thing. What times what gets me 24? That when I add them together, I get my B term, which is negative 10. And I tried some things, and I got negative 6 and negative 4. And what I did is I just rewrote, I took my negative 10x and I broke it into the two pieces, the negative 4x and negative 6x, and I wrote my whole equation, 8x squared minus 4x minus 6x plus 3, and I did grouping. And one thing I just had to keep an eye on was this guy right here, watching him track all the way through, and keep in mind that when I'm subtracting this whole piece, that actually means that that symbol has to change to negative. So keep an eye on your negatives. That's a tricky thing, and it's a detail that's really important to this. So that's if my A term is influenced. Now here's a couple where if I'm running into perfect squares, like x squared minus 9, again, got to be careful on that one and look at that as x plus 3 times x minus 3. I also with x squared plus 36, same thing. It's x squared plus 6 squared. So more squareds is if my coefficient is bigger, if it's not 1, but it's like something like 64 or 81. And looking at that and ending with 8x plus 9y times 8x minus 9y. Also keep an eye on if my A term and my C term are both prime. And in that case, I don't really have a whole lot of options. So for my first one here, which is showing in red, my 2 has to be a 2 and a 1, and my 17 has to be a 1 and a 17. And there's only so many limited combinations with that. So I was able to do that. So let's try it out. We're going to factor out the GCF. Let's go ahead and get started with this process. So in this one, I found out that I could factor out 4p. Again, for each one of these, why don't you press pause, maybe you work it out and see how I did it, see how we're doing. I get 3p plus 4p squared plus 2. And then I'm going to rewrite this, but I'm going to put it in the right notation with the highest degree first. 4p squared plus 3p plus 2. Second one, why don't you also press pause? Keep working through these. I'm going to factor out 3b, and I end up with b to the third minus 3b plus 2. And again, that is an order of degree. Factor completely. So number 9, I'm going to need to look at something that's going to get me negative 24 when I multiply them together, but when I add them together, I get 2. And I tried a few things, and I found that negative 4 and 6 get me negative 24, and when I add them together, I get 2. So that tells me that both of those have to be x, and I'm going to have a negative 4 and a 6. Number 11 here, I have, for this one, I have to factor something out. I can factor out a 5 and an x, and I end up with 3x minus 4, and that is completely factored. That's all I can do on this one. Factor completely. Okay, I have some perfect squares on this one. I see a 25, and I see a 100. That's kind of nice. So that means that I already see a 5x and a 10. And it's minus, so it's going to be another 5x and a 10. These are little shortcuts you want to work through. Because my middle term is gone, there's no b term, that means this has to be positive and that has to be negative. Because I end up with a 50x and a negative 50x, which cancel each other out. All right, number 13, looks like I have a prime number and a prime number, which is nice. So that means that I know that I'm going to have a 3x and an x, that I already know. And then I'm looking at my 5 and what's going to create my 5. That's also going to get me to a negative 2. So I know I'm going to be working with negative 5 and 1. It's just what order to put them in. And I tried this. And I found out that that did indeed work, because I end up with a negative 5x and a 3x, which left me with a negative 2x. And you might have to try both just to see if it's true. So don't just write them down, but verify that they are in the right order. Okay, what do we got here? We have a perfect square trinomial. A term, 1 is actually a perfect square, and 25. So that tells me that I need an x, and I know it's going to be a 5, and I know it's going to be a 5. So 25, and I need to get to a negative 10. So what times what gets me 25? That when I add them to get them to negative 10, it is negative 5 on both of them. So they're both going to be negative 5. So to write this in the most simplified form is x minus 5 squared. Factor completely. All right, let's take a look at these guys. I can factor out, so first thing I'm going to do is look for the GCF, which is 4. So I can pull a 4 out. I end up with x squared minus 3x plus 2. 4 times. Now, oh, look at that. Okay, prime numbers, so I know it's going to be an x and an x. I know my 2 is only going to give me an option of 2 and 1. Okay, so I'll just do this anyway. So what times what gets me 2? That when I add them together, I get -3. So it's a -2 and a -1. So -2 and -1, and that is completely factored. Let's take a look at number 16. Ooh, we got a perfect square here, an 81 and a 49, and my x is squared, so that's nice. So I know I'm going to end up with a 9x, and I am going to have a 7. In fact, I'm going to have 2 of those. And I'm just going to write them anyway, because see if I can even simplify it more. Because of the negative here, it cancels out that middle term. So this one has to be a negative, and that one has to be a positive. And this one is now completely factored. Number 17. My goodness, they keep coming. How exciting. All right, number 17. This one's a kind of a unique one. I had, when I first looked at this one, I tried a few different things, but I eventually came back and said, let me just factor something out. So I factored out a 4 to see if that helps me see what's going on. I saw the perfect squares, so you can work with those if you'd like. I tried factoring out the 4, just out of habit, to see what that does for me. And I still end up with perfect squares of 4 and -25. So with the 4 and -25, I multiplied those together, and I ended up with -100. And I'm trying to get to that 15. And I end up with -5 and 20 were my 2 numbers. So I'm going to keep my middle term here. And again, you might have worked out something with the 4 and the -25, which would be awesome. Probably a quicker way to do this. So 4 times, I broke the 15x into the -5 and the 20, these two pieces. So I have 4x squared plus 20x minus 5x minus 25. And then at this point, I did some grouping. Grouped that and grouped that, and I factored out those things. Still keep an eye on the 4. I don't want to lose that guy. So I'm going to write him over here. And I've got a grouping of, I've got 4x squared plus 20x, and I factored out a 4x out of that. And I put x plus 5. And I have 5x minus 25, and I'm going to factor a 5 out of that. And I keep in mind this changes. So it's going to be x plus 5. And it doesn't change just to change. It changes because of this negative right here. So I'm taking that all away. So now I'm left with 4 times 4x minus 5, which I get from here, times x plus 5, which I get from here. And that is number 17 in a completely factored form. Whew, these things are getting big. Whew, here's another one, number 22, another beefy one. Why don't you give this one a try? I'm looking at the 5 and the 12. No perfect squares, no prime numbers. I'm kind of left with working with the -60, which I get from 5 times -12. And I have to add up to 11. And I tried a few different things, and I ended up with 15 and -4 when I did this one. So that leaves me with 5x squared, and I took my 11x and broke it into 15x and 4x. And then I did my grouping. I factored out a 5x, x plus 7, minus, and I factored a 4, x plus 3. Hey, wait a minute, that's not a 7. Can't be a 7, that wouldn't work. If it did show up as a 7, then I'd have to try something different. That can happen, but it's x plus 3, which is better news. And so I end up with 5x minus 4 and x plus 3 as my final factoring of number 22. Number 24. Okay, I have a 2 and a 2, which is good. Both prime. You know what, this one, I'm going to have to do some factoring on this one. Again, you might find a little bit of a quicker way to do it. I'm going to do the 2 times the -2, which is going to get me to -4, and I need to end up with at the 3. So what times what gets me -4? When I add them together, I get the 3. That's going to be a 4 and a -1. So I end up with 2x squared, and I'm taking my 3x and breaking it into 4x minus x minus 2. Let's see, get some groupings going here. This guy and this guy. I'm going to factor out a 2x. So I end up with x plus 2 minus nothing. Nothing can be factored out of that. So I'm going to make that minus x minus 2. That actually becomes a big addition problem. So this becomes actually plus in that one because I'm taking that away. So I end up with, let's take a look here, 2x minus 1 and x plus 2. Let me take a look at that. So that is a negative x. All right, you're hanging in there. You're doing great. Keep an eye on some of those details of what's happening with those positive and negatives. Ooh, let me look. These are the last two. The last two, couple more things we got to practice and take a look at. So looking at these guys, when I see that I'm already starting off with a third here, to the third power, I know I'm going to have to do some grouping like right away. So let's grab some groupings here, and I can factor out a 5z squared. I can factor that whole thing out, end up with 9z plus 4 and plus 9z plus 4. And that's nice, because then I end up with 5z squared plus 1 and 9z plus 4. And I cannot factor out the 5z squared plus 1. Sometimes you can factor that even more, but that 5z squared plus 1 cannot be factored anymore. So that is now factored completely. Second, for number 26, our last one, our finale, I'm going to do some grouping here. So I can factor out b squared out of this guy, and I'm left with 11b minus b, okay, plus, and I'm left with 11b minus 6. Oh man, my b's and my 6's are all starting to look the same. So that's a b, there's a 6. Oh my god, I don't want to lose that. Okay. And I end up with b squared plus 1 and 11b minus 6, a true 6. And I'm going to go ahead and look at my b squared plus 1 and see, can I factor that anymore? And if I can, I need to do that because I want to factor completely. But in this case, I cannot factor this anymore. So this is my final answer. Whew. All right, thanks for hanging in there. Thanks for working hard and practicing all this stuff. Go grab some of those details. Keep an eye on your negatives. And if you see a llama, make sure you are nice to it, because today is National Be Nice to a Llama Day.